Continuing on with solving our quadratic equations, we're looking at example 3 here. Now you'll see that this is not in its factored form, and we don't just have x appearing once. In this first example, we have both an x squared and an x term, so that means we cannot isolate, and it's not in factored form, so our options here are to do one of two things. One thing that I would try first, especially if it's a simple trinomial, is to try and factor it. Let's write it in its factored form, because as long as I can, then I can make those little mini equations and we can set them equal to 0 and solve. So, remembering our factoring rules, and if you need to get your summary sheet out, that's okay. If you look at this, we want to add to -5 and multiply to +6. So I think -2 and -3 will do that. And because this is a simple trinomial, we can go directly to the factored form here. We're going to have a factor of x minus 2 and a second factor of x minus 3. And if you were to actually expand and simplify that, you will see that you get the original quadratic that we had. So we know we've done it right. And then we do what we were just doing on the last one. X minus 2 would equal 0, so that means x equals 2. X minus 3 equals 0, which means x equals 3. So two solutions for that. If I were to sub the 2 into the original equation, 2 squared, so right here, putting it right there. Okay, 2 times 2 is 4, minus 5 times 2 would be minus 10. 4 minus 10 is minus 6, minus 6 plus 6. Yep, does make that equal to 0. Likewise, 3 squared is 9. 9 minus 15 is minus 6, and then minus 6 plus 6, yep, that's equal to 0. All right, part B, again, I would try factoring that. I've got everything on one side. I have both an x squared and an x term, so I cannot isolate. I'm looking for two numbers that are going to add to 12 and multiply to 36. 9 times 4. Remember, it's the product of these two numbers is what we're multiplying to here. Oh, I see something about this. This is going to give us a plus 6 and a plus 6. 6 and 6 will do that. So, because those two numbers are the same, this actually will factor as a difference of squares. So, I'm going to go to the shortcut here. Notice this is a perfect square, 4x squared, and the 9 is a perfect square. Square root the first, we get 2x. Put it at the beginnings of the brackets. Square root the last. Put it at the ends, and this one, they're both going to be pluses here. I could have actually just done 2x plus 3 all to the exponent of 2. And in fact, that's how I had taught the previous one, so that's what I am going to do with that. 2x plus 3 to the exponent of 2 is equal to 0. If we were to take the product of the two things we have, 2x times 3, and double it, times by 2, that's a times sign, not another x. Let me just make that in brackets so I don't get x's and timeses confused. That's going to give us 6. That'll give us our 12x. So it does factor like that. Because we get the two factors that are exactly the same, there's really only one solution for that. And let me write those steps in. I'm jumping ahead of myself here. Let me write the steps in. We're going to have 2x plus 3 would have to equal 0. Subtract 3 from both sides. We're going to get 2x equals -3. Divide both sides by 2. X equals -3 over 2. All right, so only one solution. If we think of the graph of that one, that's y equals the related quadratic function or graph. We're going to get that one x-intercept, and because it has the order 2, it's a bounce off that x-axis. The vertex is at that value. All right, part C is a little bit different because I don't have it equaling 0. I do have that x squared and the x term. We want to get 0 here. So we're going to subtract 3 from both sides. We're going to write that as 8x squared plus 10x minus 3 equaling 0 here. Okay, and then we're going to do our adds to and multiplies to, and hopefully this will work. We've got a 10, we've got a -24. I think, let me see, 8 and 3, nope, 8 and 3 is not going to work. I need my signs to be opposites, and the larger number has to be a positive. Let's try 12 and 2, 12 and -2. Oh, there it is, there's the one. Okay, now this is not one of the shortcuts. I'm going to have to grunt through that decomposition method here 8x squared, I'm going to put my plus, I'm going to put the minus 2x with the 8x squared. I'm going to put the plus 12x and the minus 3 together. You can do it the other way. It should still work out. It'll all work out in the wash, as they say. Out of these two, we have a common 2x. I can see Simon's rolling his eyes at me now. Minus, we're going to end up with 4x minus 1 in the bracket. Out of the next pair, I would have a plus 3 in common. Plus 3, that's going to have a 4x and a minus 1 here. And then we have a 4x minus 1 that's common to both. So 4x minus 1. And we have a 2x plus 3, and that all equals 0. And now we've got our factored form. So these little mini equations we're going to solve. I'm going to add 1 to both sides, and then divide both sides by 4. Whoops. There's my eraser. There we go. We'll divide both sides by 4. We're going to get x equals 1/4. 1/4 or 0.25. We're going to have a 2x plus 3 equaling 0. Subtract 3 from both sides. Divide both sides by 2. X equals -3/2. All right, this last one, let's try it and see how we do here. Looking for two numbers that are going to add to -5 and multiply to -2. Okay, so I know 1 times 2 will multiply to give me 2. One of them has to be positive, one has to be negative because I'm multiplying to a negative. The bigger number has to be my negative O, but that's going to add to -1. So this one won't factor. So that's a new case. That's what our last example is going to be looking at. All right, so our key idea here is if we have that quadratic in its standard form or almost standard form like C, we're going to make sure we do have 0 on one side of the equal sign, and then we try factoring here. So that factor won't factor 1. The a is always your coefficient of your x squared. So in this case, a equals 1, our b equals -5, and our c equals -2. So x equals -b plus or minus square root b squared minus 4ac, all divided by 2a. Okay, so we get -5 will be +5, plus or minus, and then we have 25 plus 8. I believe 25 plus 8 would be, brain is very tired, 33. And that's all divided by 2. 2 times 1. So we have our one answer of x equals 5 plus the square root of 33. Make sure you hit equals to get that answer before you do your divide by 2. Or if you're putting it in your calculator all in one step, make sure that you use brackets around the 5 plus the square root of 33. All right, 5 plus 33 square rooted. Okay, and then divided by 2. I think, if I've done this correctly in my tiredness here, I think we get 5.37 approximately as our answer. So I've rounded that, and then we have x equals +5, subtract the square root of 33, all divided by 2. 5 subtract the square root of 33 equals that, divide by 2 equals -0.37 approximately. Okay, so now we're going to use that quadratic formula on the next two examples. Why don't you give it a try and see what you get? All right. Okay, so when the quadratic equation is in its standard form, make sure you have 0 on one side of the equal sign. Try to factor it, and if you can, then set each factor equal to 0 and solve the mini equations. Now the question is, what if you can't, like that last example? Well, if you can't factor it, then we have this thing, our friend called the quadratic, oops, that's not what I meant to do. We have our friend called the quadratic formula that we're going to use for that. There we go. Okay, so we're going to use the quadratic formula when we cannot factor it. So if we go back to that last example, you need to remember what that quadratic formula is. And I'm going to write that in here as well. Okay, so if it won't factor, we want to use the quadratic formula, and that's the one that we have ingrained in your brain with that song, and I will try and put a link to the song to our classroom, and I'm going to really irritate you with my very poor singing skills, but that quadratic formula goes like this. It's x equals negative b plus or minus square root b squared minus 4ac all divided, there we go, all divided by 2a. Okay, so that hopefully has lived in your brain and has not gone away. If not, just listen to the song once or twice and I'm sure you'll have it again. So we're going to go back to the example that did not factor. Okay, so for part A, I ended up with the square root of 0 underneath, a 0 underneath my square root sign. And what that really means is that this plus or minus piece becomes like irrelevant, where you just get 6 plus 0, which is 6, divided by 2, which is 3, or we get 6 minus 0, which is 6, divided by 2 is still 3. So this one actually did factor. This one you could factor. You're going to get, if you look at that as y equals x squared minus 6x plus 9, you're going to get the parabola with the vertex sitting right on the x-axis, and we're bouncing off of that x-axis at that 0. So you can get a positive answer like we did in the previous one that we've done under the square root. You could get a 0 under the square root, or this one I got a negative under the square root, which we cannot take the square root of a negative number. You're going to get an error on your calculator. So this has no answer in the real number system. What this means is this parabola is an opening up parabola if I had y equals this instead of equaling 0. And because it's opening up, my vertex is above the x-axis and it's never actually going to have any x-intercepts. So this one has no solution to it. There's no value of x that would ever make that equation true. Okay, now that piece underneath the square root sign, that b squared minus 4ac, we've talked about in 3M and in grade 10 academic, depending which route you took. This is called the discriminant because it distinguishes or discriminates between whether you have one solution, two solutions, or no solutions. Discriminant. Okay, if it's positive, there's two solutions. If it's equal to 0, there's only one solution. And if it's negative, you're going to get no solutions. Okay, so if it's negative, you might want to summarize that here. Okay, and that's it for our lesson. All right, and I've just put that little summary right here if you want to highlight that and write that in your notes as well.